In the second half of 5.3, we're going to continue in the exact same fashion. So we're solving equations. Again, make sure that you read the directions. Solve. These questions look very similar, very, very similar to proofs. The difference is the directions. So if I'm solving this, so I'm going to go ahead. Oh, this one's kind of a mess. We've got multiple x's inside two very different trig that we have to get to. Now, I know that sine squared and cosine squared have a Pythagorean identity, but neither one of these is squared. So I think I'm going to separate them, put sine on one side, cosine on the other, and then I'm going to square. So I'm going to leave the sine x plus 1 on the left, and I'm just going to add the cosine x to the other side. So I am going to square each of the sides. Now, way back in integrated 3, I think is when we did this. Yeah, back in integrated 3. If you introduce an additional variable into a problem, which is really what I'm doing here, I am squaring a trig that has the variable in it. So I am creating more of the variable. You have to at the end. So when you do this, you have to check for extraneous solutions. It's possible that you introduced something that didn't really belong there. So here's your quick little aside, just tiny, tiny little aside. These types of problems are similar to stuff like that from last year, where you would square both sides, which is all fine and dandy, but this actually, the right-hand side specifically, you just doubled the amount of x's that you had. And I'm not saying times 2, like you multiplied an additional x inside. You had possible extraneous solutions. So you might have extra solutions, and those extra solutions might not work. So you got to make sure at the end that we make sure everything actually works. All right, let's multiply this out. So sine x plus 1 times sine x plus 1. You might want to draw out the boxes if you need to. This is sine squared x plus 2 sine x plus 1 is equal to cosine squared x. Okay, so I've introduced some variables, so a squared, which is great because then I can get the sine squared and the cosine squared together. The problem is right now is that I have to figure out who I'm supposed to use the identity for. And to me, there's one giveaway. If you take a look at all of these pieces, there's only one of them that doesn't have a squared. And it's the sine x, which means you're stuck with sine. So the cosine has got to go. So replace cosine squared. And really, it's because the only trig in here that's not squared is the sine, which means you're stuck with sine. So turn everybody into sines then. So we'll bring down the sine squared x plus 1. And then the 2 sine x that we already had over there. Let's replace the cosine squared x with 1 minus sine squared x. So Pythagorean identity. Okay, all the trig matches. That's big. We have some squareds in here. Well, actually, it's more so that the trig matches. Put everybody on the same side together. So let's add the sine squared. So I'm going to get 2 sine squared x plus 2 sine x minus the 1. Those cancel. Factor. So they each have a 2 sine x in common. So this is going to be 2 sine x plus 1 is equal to 0. Use 0 product property. 2 sine x equals 0. 2 sine x plus 1 equals 0. Divide by 2, so sine x equals 0. Okay, where does sine equal 0? Sine equals 0. There and there. So 0 and pi. Then this one, now because there's possible extraneous, I'm not going to try to loop anything together until I know what works. So subtract the 1, divide by 2. Okay, where does sine equal negative half? I don't want that to be very tall, and it needs to go down. So there and there. So this is going to be at 7 pi over 6, and this one's going to be at 11 pi over 6. Okay, I need to figure out... Oh, I forgot. I left my 2 in. My apologies. Let's go back and fix this before we continue, because this thing is going to be completely wrong. So remember, I factored out a GCF of 2, which means that wasn't there anymore. All right, let's fix it. So we've got sine x is equal to negative 1. All right, totally different. That is down here. So sine x is equal to negative 1 at 3 pi over 2. All right, I got to check. I don't know which one of these is going to work. It might be that all of them do, and then I'll figure out if I can loop them together. Or it might be that none of them work, or maybe one of them works. I don't know. So what I'm going to do is I'm going to go back to the original. So the very original, the first one I'm going to check is x equals 0. So that gives me sine 0 plus 1 minus cosine 0. And I'm trying to figure out if that's actually 0. Okay, sine of 0 is 0 plus 1 minus cosine of 0 is 1. Yes, this is 0 equals 0. Okay, this one works. So x equals 0 is going to be one of the answers that works. Okay, let's try x equals pi. So this is going to give me sine of pi plus 1 minus cosine of pi. Is that equal to 0? I'm just plugging it back into the original equation. Okay, sine of pi is 0 plus 1 minus cosine of pi is negative 1. This is not true. 2 does not equal 0. So x equals pi does not work. Let's get that guy out of there. Okay, let's try 3 pi over 2. So I've got x is equal to 3 pi over 2. I'm going to plug it in. So that's going to be sine of 3 pi over 2 plus 1 minus cosine of 3 pi over 2. Is that equal to 0? Okay, sine of 3 pi over 2 is negative 1 plus 1 minus cosine of 3 pi over 2 is equal to 0. This is correct. 0 equals 0. This one works. So 3 pi over 2 is it. Okay, well, if I put 0 and 3 pi over 2 on the same, so there's my 0, there's my 3 pi over 2. There's no way I can get these to loop. Look at how close and how far. So I'm going to have to write them separately. Okay, so I'm going to have x is equal to 0 plus or minus, got to loop all the way around, 2 pi n. And then I'm going to have x is equal to 3 pi over 2 plus or minus, got to loop all the way around, 2 pi n. So you got to remember, if at any point in time you introduced an additional variable into the problem, you got to check at the end and make sure everything actually works. Okay, next one. Cosine x plus 3 equals 0. Okay, this one's not nearly as bad. Let's go ahead and subtract the 3 to the other side. I'm going to put a 1 under that. So as a reminder, cosine is adjacent over hypotenuse. It's not possible for the adjacent side to have a greater magnitude or be longer than the hypotenuse. This isn't possible. This is D&E. There's no solutions here. So there's no solution. It is simply impossible to have a triangle where the cosine has a ratio that's bigger than 1. That doesn't make any sense at all. Okay, let's take a look at the next one. Okay, all the trig matches. That's great. Now let's put everybody together. So let's do 4 sine squared x plus 2 root 3 sine x. I'm just going to put the minus 2 sine x next. So I'm just going to subtract it from the other side. Okay, I have 4 terms. I think I'm going to try factoring by grouping. So I'm going to put the first 2 together, and then I'm going to put a plus sign, and I'm going to put the second 2 together. if this is going to work, after I take the GCF out of the first one, you have to be able to match the parentheses. Otherwise, it's not going to work this way, and we'll have to figure something else out. Okay, so I can take a 2 sine x. All right, so that's going to give me 2 sine x. I'll be a bit more careful, hopefully, with my 2's this time. Take that out, plus root 3. Okay, so if this is going to work, I better get a 2 sine x plus root 3. Okay, that's good. I just need to take out a negative sign. So negative 1, 2 sine x plus root 3. Drop down my equals 0. They both have that 2 sine x plus root 3 in common, so that's my new GCF. So 2 sine x plus root 3, that's the new GCF. Remember, we go back and we find all the stuff that was left over. That creates my second set of parentheses. So I have 2 sine x minus 1. Equals 0. Okay, 0 product property. 2 sine x plus root 3 equals 0. Two sine x is equal to negative root 3. And then whenever you want to try these on your own, and hopefully you are pausing, just pause them and come back and check. Okay, sine x is equal to negative root 3 over 2. Okay, sine x is equal to negative root 3 over 2. That's tall and down. So there and there. So I have a 4 pi over 3 here, and I have a 5 pi over 3 here. Okay, let's take a look at the other guy. So I've got 2 sine x minus 1 equals 0. 2 sine x equals 1. Divide. Sine x is equal to a half. Okay. So sine x, so I do want to move this one over there and see if I can wrap stuff up. Okay, so I want tall, not tall, actually pretty short. So this is going to be at pi over 6, and this is going to be at 5 pi over 6. Okay, let's grab this, copy it, move it over here, transpose. Done. Okay, let's see. I don't think so. We could do, well, you can't with just the pi over 6s. Those are way too far apart from each other, or super close in some regions. And we have the exact same thing with the pi over 3s. There's no consistent distance here. Let's get rid of that guy. Okay, so I've got my first one, and I'm not going to check for extraneous solutions because I didn't introduce another variable. It's not like I squared or multiplied by x in the beginning. So I've got 4 pi over 3 plus or minus, have to do a full loop, 2 pi n. And then I've got 5 pi over 3 plus or minus, I got to do a full loop, 2 pi n. Okay, that's the guys from the first part. Now let's go to the next one. Those can't be looped together, so x equals pi over 6 plus or minus, got to do a full loop to get back to it, 2 pi n. And then x is equal to 5 pi over 6, got to do a full loop, 2 pi n. And I do need to give all 4 of them. All 4 of them are technically the answer. Okay, let's take a look at question number 4. Well, there's no constant in here, so that's actually kind of nice. I think we can approach this a couple of different ways. So let's see. I'm going to separate them for sure. So let's do sine x is equal to cosine x. Okay, intuitively speaking, sine and cosine are the same in 45, 45, 90 triangle, so pi over 4s. But you need the signs to match, like the positives and negatives. So we could actually just go from here, I think. I want both the sine value and the cosine value to be the same. So positive, positive, pi over 4. That one works. And negative, negative, pi over 4. That works. So I think I've got a pi over 4. And then this one down here is going to give me 5 pi over 4. And I know that those actually do have a consistent distance between them. That's going to be plus pi. Okay, so I think one way we could have approached it is just, let's think about it. Where do sine and cosine equal. Okay, so that's one way to approach it. Let's say that that's not really what struck you. So let's approach it a different way. We'll get the exact same thing. So sine x is equal to cosine x. Remember I said you can't divide out a variable. Don't do that. But you can rewrite it. So if I were to manipulate this by turning it into, so like that right there, I'm turning it into tangent. So this says tangent is equal to 1. So I didn't cancel cosine x on both sides of the equation. I manipulated the equation to rewrite it as a different trig function. I didn't cancel anything out. Well, I can do the same thing here. So where does tangent equal 1? Well, tangent equals 1 at pi over 4, and tangent equals 1 at 5 pi over 4. Thus you get the exact same answer. So if you didn't go where does sine equal cosine? You could just manipulate it to become tangent. That's fine. Okay, let's take a look. Okay, question number 5. Put it on a different screen. Previous one didn't need a whole heck of a lot of room. This one, though, this one's different. This is a multi-angle. So if I take a look at the theta inside, it's not just x. It's not just theta. It's not just u or b or alpha or gamma or whatever. The only thing that we know how to handle is a single angle so far. So I propose that we use u substitution. I am going to let u equal 4x. I'll come back to that at the end. So what I'm going to do is I'm going to rewrite this as cosine of u, so it's just a single variable, like normal, is equal to negative root 2 over 2. And I'm going to treat it like it's a regular problem. You could even call it theta if you want to. Just don't call it x. X is already taken. So let's take a look at where u is equal to, or cosine of u is equal to negative root 2 over 2. Okay, so negative root 2 over 2, well, those are pi over 4s, and I want my x value to be negative. So right there and right there. So I think this is going to be at 3 pi over 4, and this one's going to be at 5 pi over 4. Now, they don't have a consistent distance in between them. Okay, those are my u's, though. So here's what I'm going to do. I'm going to write out u equals, well, my first answer was 3 pi over 4. The distance to get back to it is a full loop, so 2 pi n. My other u would have been 5 pi over 4, plus or minus, had to do a full loop to get back to it. Okay, one of the things with u substitution, which we did first semester, you got to make sure you resub back at the end. So if I take a look back over here on the left-hand side that is highlighted in orange, I let u equal 4x. So where I see u's, I'm going to replace it with 4x. I am resubbing back in, and then carry down what's on the other side. And I have to do it for both of them. What you have to do is you have to solve for x. X was the original variable, so that's what you need to solve for. If I divide by 4, then this is going to be 3 pi over 16 plus or minus 2 pi n over 4. You could have simplified it, 2 pi n over 2, totally fine. You got to do the same thing here. X equals, divide by 4, that's 5 pi over 16 plus or minus 2 pi n over 4. You could have also simplified. You have to make sure that you resub your variable back in and solve for the thing that you were originally supposed to be solving for. Okay, next question. We have another multi-angle again. So I have a 3x this time. So I'm going to let, and you can do u, you can do theta. You just cannot use the variable that's already there. So I'm going to do u again equal 3x. And I got to remember to come back and do that. So this is going to be 2 cosine u minus 1 equals 0. Now solve like normal. So 2 cosine u equals 1. This is going to be cosine u equals a half. Okay, so cosine is equal to a half here and here. So those are going to actually, let's color code them in orange since we are looking for the u's. Okay, so this is going to be at pi over 3, and this is going to be at 5 pi over 3. There's no way I can loop those together. That can't happen. So I have that u equals pi over 3 plus or minus. You got to do a full loop to get back to it, 2 pi n. And u is equal to our second answer, which was 5 pi over 3, plus or minus, full loop, 2 pi n. Okay, now you have to resub. You have to. So remember, on the left-hand side highlighted, u was equal to 3x. So replace your u with a 3x. Copy down the right-hand side on both of them. X is equal to 5 pi over 3 plus or minus 2 pi n. Now, remember, you still have to solve for x. Whatever the original variable is, that's what your answer needs to be. If it was thetas, then your answer is thetas. If it was x's, your answer is x's. If it's alphas, it's alphas. So I'm going to do x is equal to, I'm going to have to divide by 3. And then divide by 3. Make sure you give both of these as your answers and that you're answering the original question. The original question was x's, you give x's. Okay, let's take a look at this guy. Oh, got a multi-angle again. Actually, this time it's half. I haven't done that yet. So let's let u equal x over 2, and then just turn it back into a regular problem. So 3 tan, put your u in there, and then plus 3 is equal to 0. Okay, so 3 tan u equals negative 3, divide. So tan u is equal to negative 1. Okay, where does tangent equal negative 1? Okay, tangent equals negative 1. It's some pi over 4s, and it's those guys. Okay, so let's see. This is going to be at 3 pi over 4. And this one is at 7 pi over 4. And there is a consistent distance on this one. So we can go ahead and loop these together. So that distance on both of them is going to be plus or minus pi. All right, so u equals, and then just pick one of them, whichever one you want to start with, 3 pi over 4, plus or minus pi n. So remember, pi is the distance between both of them, so we could loop them all together. Okay, but you got to resub. So if we go back, u was equal to x over 2. So x over 2 is equal to, and then carry down your 3 pi over 4 plus or minus pi n. You got to solve for x. This time I'm going to times by 2. So x is equal to, so this is going to be 3 pi over 2, or you could leave it as 6 pi over 4. They're the exact same thing. Plus or minus, times that by 2, 2 pi n. Okay, let's take a look at this guy. And I think this is the last one for our notes. The trig all matches. That's great. I've got a squared, a non-squared, an equal sign, and a constant, and put everybody on the same side together. So let's do cosecant squared minus 3 cosecant x plus 2 equals 0. I'm going to factor. So boxes and diamonds, cosecant x. When I factor, I get a minus 2 and a minus 1. Zero product property. Cosecant x minus 2 equals 0. So cosecant x is equal to 2, which really means sine is equal to the reciprocal, which is half. Okay, sine is a half. So not tall, but up. Okay, so I'm at pi over 6, and I'm at 5 pi over 6. Okay, let's do the other one. This is cosecant x minus 1 is equal to 0. So cosecant x is equal to 1. So sine x, well, the reciprocal of 1 is just 1. Let's color code this, and I'll impose it on the other one and see if I could loop them together. That's up here. So that's going to be at pi over 2. I don't think it's going to happen. It's going to look like they're super close together on the top. Yeah, I don't think it's going to work. So if I look at this, I have same distance, and then not even close to the same distance. I don't think it's going to work. Let's get rid of the green guy. So I think we got to write everybody separately. So we're going to get, well, let's see, x equals, this wasn't a multi-angle, and I did check to make sure. So I have x is equal to pi over 6 plus or minus. You got to do a full loop to get back to it, 2 pi n. And then I had 5 pi over 6 plus or minus full loop to get back to it, 2 pi n. So those are those answers, but I think we still have the pi over 2 answer. Now we have x is equal to pi over 2 plus or minus 2 pi n. And yeah, we got to make sure we give all of them.